All right, today's lesson is simplifying expressions. We're going to do standard 6EE3, applying and extending understanding of our number sense to our algebraic sense. So we're going to start to combine our like terms today.
In an earlier lesson, we talked about the vocabulary term like terms, terms that have the same variables to them. So in our example over here, we have 6y plus 3 plus 3y. 6y and 3y are both our like terms. So what we're going to work on today is we're going to simplify the expression, basically kind of combine some pieces together, make it a little easier to get through by looking for those like terms. Those are the pieces that we can combine together. So think of that y standing for yo-yos. Somebody has 6 yo-yos, somebody else has 3 yo-yos, so we would say they have 9 yo-yos all together. We combine those like terms. But if they're not like terms, we're going to keep them as separate pieces. So that 3 doesn't have a y. It's not a like term. So that plus 3 just stays as a separate piece. We combine the like ones, but leave the rest of them there.
And a couple of students are asking questions, what do I do next? You're done. 9y plus 3 is the simplified expression. We're not putting any value in for y. 9y plus 3 is simplified, so you're finished.
Yep, it's hard to kind of get used to that, but most of these problems you're going to have at least 2 or 3 terms left by the time you're done with the problem.
All right, the directions are simplify the expressions by combining any like terms together. You're going to be working with addition or multiplication. So here we go. We've got a 4x plus a 6 plus a 2x. We have to identify our like terms. Mr. McKenzie's going to go through and either, we're going to have to pause. Hold on.
Mrs. Guerin, please contact the main office at extension 2709. Mrs. Guerin.
All right, so he's circling his like terms just to visualize what he has to combine together. So he has 4x plus 2x, so he's going to combine that together and make it 6x. And then when he goes through his process, he underlines constants. In case there's more than one, he would catch those as like terms as well. In this case, there is only one, so he leaves it as 6x plus 6 as a simplified expression.
No, don't try to make that into 12x. You can't combine those together. They're not like terms. Our simplified expression is just 6x plus 6. Next one over here. If you remember earlier in our variable and expressions lesson, when a number is right next to a set of parentheses, that's really code for we want to multiply times whatever's inside the parentheses. Inside we have an x. Remember, if you have just a single variable, we always want to write in that 1. So it's really 9 times 1x. So combining like terms, we can use both addition or multiplication. For multiplication, you multiply the number parts together. 9 times 1 is 9. The variable just kind of tags along for a ride. So 9 times x is 9x.
All right, we're going to start our examples. We're combining like terms to make equivalent or equal expressions. So he's going to go through the first example, 8y plus 9x plus y, and he's putting a 1 in front of the y. Just reminding himself that there's that invisible 1 there, and he's going to add 8y and 1y, his like terms together, to make 9y. Now, 9x can't just stay on the left side. We got to bring it all over as well. So the left side reads 8y plus 9x plus 1y, which is equal to a total of 9y plus 9x.
All right, next one. M plus 10p plus 5m plus 6p plus 18. And make sure you're writing down the whole problem. We want to see the circles and the boxes and underlines just like we're doing before you get to that magical final answer. So anytime you're seeing a single variable, go ahead and put in that 1. You'll make a lot fewer mistakes by putting that 1 in right away. And now I want to start sorting and finding like terms. So I'm going to circle anything that has an m in it.
And box anything that has a p in it.
The shapes kind of help me identify which pieces can be combined. If it's a plain old boring old number, one of those constants, I'm going to underline it. And now I go back and combine those like terms. 1m and 5m is 6m. 10p plus 6p is 16p. And then I just have my constant of 18.
So the left side, 1m plus 10p plus 5m plus 6p plus 18 is the same thing as 6m plus 16p plus 18. All right, our third expression, we've got 3a 3 apples plus 8 bananas plus 9 plus 14. Once you have it down, go ahead and put a circle around the 3A, a box around the 8B, and underline your constants or your numbers 9 and 14. In this case, we don't have anything but one circle and one square, so we bring those over. 3A plus 8B comes over to the right, and we have to combine our constants. 9 plus 14 gives us 23.
So sometimes there's going to be like terms, sometimes there's nothing for it to be combined with, so we just bring that term over to the other side.
But don't forget to combine constants.
Now let's do the same thing, but let's use some multiplication in our problems. So 8 on the outside of our parentheses, when there's nothing in between them, tells us that we're really multiplying. So it's really 8 times 4. 8 times 4 is 32. And the x comes along for a ride. You can have the next one.
I know, but I can't write, so I feel weird not writing.
You can write.
I have
Just
to
don't
write.
screw it up.
Sorry. So we're multiplying a 3 times you want that 1 there.
I always want that
forget
1.
it. I can't slant it and write it.
You could just
Now
move it in
just
front of
go.
you. All right, so we have our 1x. So we're going to take the 3 on the outside times 1x. That's 3x. We're going to do the same thing over here. Remember, multiplication comes before addition. 2 times 4 is 8y, and those are being added together. 3x and 8y are not like terms, so I can't add those two pieces together. So my answer is just 3x plus 8y.
We really need to get in the habit of using these parentheses because x is no longer a multiplication sign. It's now a variable. In the third example, we've got 7 on the outside times the 2x inside, and 7 times 2 will give us a 14x. Please put that invisible 1x there. Carry that over. There's nothing to do with that like term but to add them together. 14x plus 1x is going to give us a total of 15x. No, you don't multiply them together. They are all the same variable.
All right, so you're just looking for that common variable. Those are the pieces we can combine together.
If not, bring them along.
So now it's your turn. Go ahead and hit pause, copy down the 4 problems, and work them out for yourself. Then hit play and see if you did the problems correctly.
All right, here we go. So we've got a W to circle, another W to circle. We got an underline a constant. Oops, he's boxing first.
I like all my variables first. Constants have to wait for the
Going
end.
in a weird order. All right. So we got 2 circles to add together, which makes 17W. We've got 7x to bring along, and 8 plus 7 gives us 15. Or 7x plus 17W plus 15. Addition is commutative.
We always like to have that constant at the end of the problem. So just kind of get used to that as you're writing it out. Always leave the constant for that last piece.
Second one, we've got a 9 on the outside of the parentheses and an 8 on the inside, which gives us 72y.
Next one, we got a little bit of multiplication and addition in here. So start multiplication. 7 times 4x is 28x plus 5x. 28x and 5x are both like terms because they both have the exact same variable. 28 plus 5 is 33x.
All right, circle, circle, circle.
Oh, and don't forget to write that invisible 1. Or you may be tempted to try and say this is just 7g.
So 2g plus 1g plus 5g is going to give us 8g.
Plus
Plus
8.
Here, please
8.
contact the main office.
Someone
Mrs.
please
Garrett.
find Miss Guerin. 8g plus 8. We are done with that problem, right?
Yep, there's no like terms here, so we are finished. And hopefully
you
we find
please-
Mrs. Guerin.
The total, put the total number you got right out of 4. 4.
4.
So we can see how you did. Thanks.